Part 7. Graphs. A tree was a strict hierarchy. One parent each, no loops allowed. A graph throws all of those rules away. Here, anything can connect to anything. And a graph is really just two things: nodes, which are the dots, and edges, the lines drawn between them. That is it. But with that one freedom, a graph can model almost anything in the world. Your friend network, the roads between cities, web pages, and the links between them. Even the dependencies between tasks on a project. All of them. Graphs. Now, edges can point both ways, like a friendship. That is undirected. Or they can point just one way, like a one-way street, or following someone who does not follow you back. That is directed. And edges can also carry weights. A road's length, a flight's cost, the strength of a connection. Now the graph holds not just who connects to whom, but how much. So how do we store one in code? There are two main ways. The adjacency list. For each node, simply keep a list of its neighbors. Compact and perfect when edges are sparse, which is almost always. Or the adjacency matrix. A big grid where cell I, j, is a 1 if I connects to j. Lookups are instant, but it costs n squared space. Wonderful for dense graphs, but wasteful for sparse ones. Nodes and edges. That is the entire alphabet. Everything we do from here is just clever ways of walking these dots and lines.